Hello guys, welcome back. This is Rosario Borgesi and in this video I will present to you Privy and how we can integrate this library inside our DApp in order to implement the account abstraction feature ERC-4337 in our DApp in a very straightforward manner. So let's get started. I've created this article on Medium that you will find in the description to guide us throughout the video. And before starting discussing Privy and how we can integrate it in our decentralized applications, I would like to give you a little bit of introduction on account abstraction and why it has been proposed. Until the creation of the account abstraction, which is ERC-4337, the Web3 dApps suffered great problems from the user experience point of view. In fact, as we know from every application that we have interacted with, we need to always have a wallet to pay for the gas fees. So we need to buy some gas from the exchange and transfer it in our wallet, and also we need to be able to sign transactions. So this is a user experience that is totally away from what the user is used to in the Web2 world. So this to give you a taste of how a Web3 application looks like until the account abstraction and why the account abstraction it is needed, we can give a look at this. This is a video game. As you see, every time the application it is interrupted because we need to sign a transaction. So the user experience it is not good. It is completely distant from a user that it is used to a Web2 application. So we needed a new feature in the decentralized application to make this application more similar to the Web2 ones, and this is account abstraction. As we said earlier, in a traditional Web3 application, the user has a wallet, which is, for example, MetaMask, which holds the private keys, and with these private keys, we can sign a transaction. In the account abstraction realm, we can sign a transaction pretty much with everything. So we can, for example, authorize a user with Google or with GitHub or with whatever social like LinkedIn, Instagram, Telegram, whatever, and the user does not need to sign any transaction. So we can also add create custom transaction rules with account abstraction. For example, we can require a multi-signature transaction where multiple users need to sign a transaction. For example, if we are afraid to lose the money in our wallet, or for example, we can set time-based restriction. For example, we allow transactions only during the day, or we can prevent transaction that overcome some spending limits, so we can keep the transaction, the amount to be transferred inside a certain range. So these are other important features, but the main feature that it is important to understand related to account abstraction, it is that the user does not need to have so a wallet, does not need to buy some fees, and does not need to sign transaction, because the account is created for the user with the account abstraction. It is created a fake account that, and there is a paymaster that can sponsor the fee, which means that for example, if the an application that creates video games wants to sponsor the fee, it can sponsor the fee for the users. So the users does not need to have a wallet to buy gas fees and also to sign transaction, because all this part will be abstracted away for the users. And so this is a crucial innovation that will really can play a pivotal role in order to bring even more people to the Web3 world, because it makes the Web3 applications even more similar to the Web2 ones. But now let's get in a little deeper and understand how it works. So as we have introduced earlier, in a traditional transaction we need an external owned account, for example a MetaMask account, that submits a transaction to an Ethereum node of the blockchain. So in the context of account abstraction, we have 5 actors: the user, the bundler, the entry point, the paymaster, and the smart account. For example, the user is the one that sends a user operation, which is a meta transaction. It is not a real transaction like the one that we have seen here. And so many users can send these user operation that are to the bundler, that bundles them inside a transaction. This transaction is before it is bundled inside a transaction, these user operation are checked, and they are transmitted to the entry point. Once they arrive to the entry point must validate that the paymaster can sponsor effectively this transaction, and then this transaction are transmitted to the smart wallet that will be responsible for executing all the user operation inside the transaction. This is a very complex set of operations. I have simplified it in order to help you understand how it works. But if you want to understand better how it works in a deeper way, I have left in the description the Alchemy playlist where you can where it is explained in a more profound manner. So let's understand what is Privy and why it will help us in bringing the account abstraction feature in our decentralized application. So Privy is an SDK that allows multiple login options, customizable UIs, and it enables to create self-custodial embedded allow to create self-custodial embedded wallets. This will be clear as we go on the video. So this is an example of how a login looks like in Privy. As you see, there are we can set different types of authentication, for example, by mail, by SMS, by with Google, with Twitter, or with other social, or with a wallet, for example, MetaMask, with other social, for example, with Discord, GitHub, LinkedIn, and so on. And let's go to the tutorial part and see how we can create an application, a decentralized application with. So the first thing to do is to go to privy.io to create our dashboard. So I have already created one. So this is how the dashboard looks like. We can go inside, for example, here we can see that we have the we can set the login methods, so we can choose email, SMS, external wallets, for example, MetaMask, passkeys, and so on. We can also choose the social. For example, I've chosen here Forecaster, but we can choose to, for example, implement Google. We have to provide, of course, the credential. This is also valid for all the other social with, for example, X, GitHub, Discord, LinkedIn, and so on. And we can also, here there is the part where we can set the smart wallets, so the smart account. For example, here I have selected the light account by Alchemy, but there are also other options, for example, Bigonomy, Safe, and Kernel. And we can also configure the chain. For example, here I have selected Base Evolia because we can use Base Evolia, and I have inside the bundle URL and paymaster URL, I have put the API key that I have created from Pimlico. But you can also put the here the bundler or paymaster URL by other providers. So let's get back to our tutorial. So we go in our terminal, we create a directory. Okay. Okay, now we create a basic and Next.js application. Okay, it is calling, it is creating it's asking me the name of the project, so I will give my app. TypeScript yes, Slint yes, Tailwind yes, SRC no, yes, no. Okay. Okay, once it has finished, we go inside this folder that it has created. Okay, now we can add the for example Next UI. This is just for styling, but we add it . Once it has been installed, we need to modify the file tailwind.config.ts this way. Okay, so now we need to copy this code here. Okay, perfect. Then we need to install the Privy library. No. Let's do it from here. Oh, sorry. I did not copied this line, maybe. That's why it did not work. Okay, now it should work. Okay, once it has finished, we need to create a file inside our root called here. So new file .env.local, where we should put the Privy app ID of our Privy API key, and this is the one that we get from the dashboard. The one that we have once you create the account with Privy, you get the API, the ID of your app, and you can put it here. Okay, once this is done, we should create a file called providers, where we basically put this is the provider for Next UI that we have installed before, and then we have to add the provider for Privy. As you can see here, it takes the Privy app ID that we put inside the file .env.local. So, and also here there are some configuration for Privy. For example, here we are stating that each time the user logs in, we will create an embedded wallet, and we are stating also that the default chain is we are using the base Polia chain, and so we need in our application to create a new folder here that we call components, and we create a new file that we call providers.tsx. Okay, and this is the code that we need. So basically it is the same code that it is in the article plus the various imports. So at this moment we have the Next UI provider, the Privy provider, which are configured. This is the smart wallets provider also from Privy, and now we should take this component that we have created and should put it in our layout page, so that every page gets inherits the Privy configuration and the Next UI configuration. So here we can delete all this stuff which we don't need. We can import the component provider that we have created before. Also we use this import this thing here, which is useful. We configure it here. we use it here. Okay, now here we can put create my private app. Here we put Privy tutorial app. Okay, and here we just need to here this part it is not needed anymore. We just we can just add this. Okay, and then we can add the provider that we have imported component, and this we can put it here. Okay, providers, right? It's not provider. Perfect. And that should be it. This is just a font that we have imported. So we have imported the configuration inside the layout, and in Next.js application it is used in all the pages of the application because it is imported in the layout. So every application will have access to Privy and to Next UI. Now, so this has been done. Let's create now a very simple page. So I will copy the code and explain it. So in our page we put this code here and we will explain it. Maybe before I discuss this application further, it is better to deploy the smart contract that we need to interact to, so we can have a better understanding of how the application works. So we need to go, we can go for example to Remix. Okay. I have a contract already that I have already created. So this is a basic ERC-721 contract for creating NFT. As you can see, there is not the owner because since we want to mint the NFT starting from our smart account. So we need this NFT to be public, so everyone can mint a new NFT in this case. And so it is basically it is just as this function. If mint we provide the address that will receive the NFT, and it basically auto increments the new the ID of the counter of the token that have been minted. So we can just deploy this contract, which is already compiled. We will deploy it to base Sepolia. Okay, which is this one. We can deploy it from here. Okay, perfect. Okay, the contract, it has been deployed. So I will copy this address and now I will create a new file, new folder lib, and inside of it a new file constants. Constants ts. They create a new variable This is not good. Okay, this is the address that we need. Okay, that we have copied before. And we also need the API that we can take from here. And we will put it inside the new file that we will call ERC-721 ABI.ts. So this should be here. Okay. And here we write export const ERC-721 ABI equal to, we copy our API as const. Okay, so now the application should find the data. Okay, let's try to start the server. npm run dev. So if I go to localhost 3000, we can find our application. So as you can see here, so we have imported basically this is the address where we have deployed our NFT contract, the contract to create ERC-721 to mint the smart contract. Here we're importing some components from NextUI. These are two hooks that Privy is giving us, and we also have this function use smart wallets that that we will use in order to get the information from the smart wallet. And then use state from React. This is the base Evolia chain that we are importing from VM. This is another function that we are using to imported from VM, and this is the API that we have imported from the contract that we have previously deployed. So we are using this hook use Privy that gives us some variables, for example ready authenticator and user, because Privy maintains the state of the user that has done the login process. And so then we have some other variables that Privy gives us in order to interact with the smart contract, with the smart wallet, sorry. And this is basically the code that you see here. So we have a Privy tutorial, your Privy tutorial app, and then we have this button here, login. And when we click this button, we call the login function, which is a login function that comes from Privy. So as we said earlier, we can login into our application, for example, with our email. So I put my email. Okay. Now in my phone I can check my the code that has arrived in my email. Okay. Now, as you can see, this is I have authenticated. I have made the login inside our my application. Here you can see this part here. So you have the login button. This is the logout button, which is this one, and this is also presented when the login. It is presented when the preview is ready, but the user is not authenticated. Vice versa, the logout button is presented when preview is ready, but and the user it is authenticated. So here we see these two fields. In this first field, embedded wallet, which is this one, we present the embedded wallet that is created by Privy, and also for the with this embedded wallet, it is used by Privy to create the smart wallet here. So the account abstraction part, the paymaster, the bundler, the whatever, the smart account, the factory are not are abstracted away from us. We don't need to implement anything, as it happens in other SDKs. So we just Privy just has created this smart wallet. We can access it this way. So here we have the smart wallet already created for us by Privy, and we just need to configure the parameters in the dashboard as we have seen earlier. And then here we have the button here, mint NFT, where we can put the address that we want that will receive our new minted NFT. Okay, so for this button, as you can see here, it calls the mint NFT transaction, which calls this function here, send transaction by Privy. We express the chain, the address of the smart contract that will mint the NFT, which is the one that we have deployed earlier, and then we encode the function data with this function by VM, where we put the API, the function that we want to call, which is safemint, and the argument that we want to pass to this function safemint, that as we have seen earlier, just receives the address, the recipient. And so here we are putting just the recipient address that we have taken from our input here. So and then we send this transaction. So here, after we, for example, I want to mint an NFT to my address. I put this address here, and I press mint NFT. Okay. After it has finished, we can see the hash of the transaction, because we are setting in the state the transaction that comes from this after we call this function, and then we can, for example, go to base Sepolia scan. Okay, in the testnet we can check this transaction. Okay, and here we can see that the first token has been minted to my first address. For example, we can also mint another token to, for example, my second address, which is this one. So if I copy here I go to my application. I paste this here. Okay, perfect. Another transaction, it has been created. And so here I should find, okay, this is the first transaction, and of course the owner is my second account. Okay, B35. Okay, so this is how basically how Privy works. As you can see, it is very easy to implement the account abstraction in our decentralized application, and we basically need to call some hook from Privy, and the account abstraction part it is abstracted away from us. We don't need to take care of the paymaster, the bundler, call the bundle call, or that function execute the user operation, estimated gas, and so on, because it is all abstracted away from us, and the Privy gives us a very simple way to onboard our user and to interact with this newly created smart account. Also, bear in mind that in this case the fees for submitting this transaction to mint this NFT are sponsored by the Pimlico API that we have provided inside the dashboard. So it is the paymaster of Pimlico that is paying the gas fee and not the user. So guys, we have reached the end of the video. I hope that it has been useful, and if you have any questions, please drop a comment and I will answer you as soon as I can. Thank you for watching, and see you in the next video.